welcome to our research project for the 9th Undergraduate Research Competition, organized by Abu Dhabi University. We are a group of students from United Arab Emirates University, and we are going to present our research project about the Hybrid Cladding Method for sustainable deep retrofitting of external walls of existing Emirati houses.
Content: we're going to talk about energy, aim of the project, hybrid deep retrofitting systems, and final goal. Energy. High energy consumption impact on the world. First, greenhouse gas emission. The building and construction sector accounted for about 39% of the process-related carbon dioxide emission in 2018. Second, climate change. Higher urban temperatures have a very serious effect on the energy consumption of the urban building. Third, economic impact. Residential buildings are responsible for almost 70% of the energy consumption of the sector. Fourth, high global environment impact. The specific environmental impact is related to the extraction, use, and waste of the resources. High energy consumption impact on the UAE. Greenhouse gas emission. The United Arab Emirates produced 203 million metric tons of carbon dioxide emission in 2020. Climate change. The UAE suffers high pollution with an 80 tons per capita emission of the greenhouse gas carbon dioxide. As a result, high temperatures worldwide. Economic impact. Climate change affecting the agriculture sector in the UAE because of the change in climatic conditions. High global environmental impact. The continuing temperature rise caused by global warming contribute to UAE's water. So the overall electricity consumption reached 130,280 gigawatts in 2020. After we measure the energy use intensity of the basic model, we find out that the total consumption of the year of the whole house is 294 kilowatt-hour per meter square per year, which is not achieving the target of energy use intensity of 140 kilowatt-hour per meter square per year that determined by the Ministry of Energy and Industry in the UAE benchmark, and does not achieving as well as the target energy use intensity of the 90 kilowatt-hour per meter square per year that defined by the Emirati Green Building Council benchmark. Aim of the project.
Aim and objectives. For starters, the aim of the project is to find the best configuration or scenarios for the proposed hybrid cladding retrofitting method for the external walls of the existing Emirati houses. That would also satisfy the local benchmark of energy use intensity in kilowatt per hour per year.
Hybrid deep retrofitting. Hybrid deep retrofitting, it depends on mixing thermal insulation, green infrastructure, and renewable energy utilization to optimize energy and environmental quality performance of the existing house. Green infrastructure is defined as the range of measures that use plant or soil systems. Renewable energy usually generated natural sources such as sun, wind, biomass, and water. Systems. Propose 3 hybrid deep retrofitting systems. First, thermal insulation cladding systems. Second, green infrastructure living wall cladding systems. Third, building integrated photovoltaic as a cladding systems. Thermal insulation cladding systems. The selected thermal insulation cladding system is Cooltherm K15 by Kingspan. The cladding system fixation method is Strata Systems, and the window film is Sun Control Window Film Prestige Exterior Series by 3M. Green infrastructure living wall. Green living wall cladding system by Versa Wall, and the irrigation system is Grey Flow BS plug and play grey water recycling.
Building integrated photovoltaic as cladding system. Selected PV panel was found to be the SunPower Maxion, which warrants a 92% power output by the product's 25th year, with up to 22.7% panel efficiency and 430 watt power rating. And for the fixation method, we have two methods decided. The adjustable wall mount that will be over the windows from backwood solar, and the operable PV louvers that will be over the opaque walls by Bremen. And as a bonus, we researched a dust repellent spray that is a nano coating spray for solar panels to prevent soiling. Soiling is a factor known for reducing efficiency of panels over the years, so we'd like to prevent that by using Percenta's nano coating spray for solar panels.
And finally, we will discuss the scenarios we studied and simulated until we achieve the final goal of this research project.
First scenario. This scenario was proposed to use the 3D model of the basic house in addition to PV solar panels of the customized BIPV system, covering 100% of north, east, south and west facades area with limestone cladding with thermal insulation, while in south and west facades, PV panels are installed in two different methods, which are louvered and overhang panels. The PV panels are installed above the windows in the main entrance to Cast Street and are tilted 66 degrees to match the latitude angle of Al Ain City in the UAE. And after subtracting the electricity output, we end up with a total yearly energy consumption of 231 kWh per meter square per year, which does not achieve the target of 140 kWh per meter square per year benchmark, as well as it does not achieve the optimum benchmark of 90 kWh per meter square per year that's set by Green Building Council. Second scenario. In this scenario, we kept the south and west elevations the same. However, we changed the north and east facades to be 50% of area covered by limestone cladding and 50% by green wall. That is designed in BIM as an external layer with a U value of 3.348 watt per meter square per Kelvin degree. And after simulation and considering the electricity output from elevations, the total energy use intensity of scenario 2 turned out to be about 227 kWh per meter square per year, which again does not achieve any of our benchmarks. In order to achieve the benchmark by the Ministry of Energy and Industry, we proposed adding a construction material to the roof, XPS rigid foam insulation with dimensions of 5 by 120 by 240 centimeters and R value of 10. So the total calculated energy use intensity in scenario 2 becomes about 108 kWh per meter square per year, but still does not fully achieve the optimum energy use intensity benchmark set by the Emirates Green Building Council. In this scenario, we attempt to achieve the target of 90 kWh per meter square per year through applying the same roof art and retrofitting, but with also increasing the area of PIPV. The total calculated energy use intensity of the developed house is about 83 kWh per meter square per year. The result of scenario 3 has achieved the target benchmark determined by the Ministry of Energy and Industry of 140 kWh per meter square per year and has exceeded the optimal energy use intensity benchmark of 90 kWh per meter square per year.